Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem 1680. Concatenation of consecutive binary numbers. It's easy mark. Let's read the question. When an integer n return the decimal value of the binary string formed by concatenating the binary representation of 1 to n in order, and we need to return answer in modulo of 10 to the power of 9 plus 7. Okay, and constants are n can be up to 10 to the power of 5. Okay, let's see one example where n is equals to 3. So what they said, we need to concatenate the binary representation from 1 to n. So we will have 1, 2 and 3. What are the binary representation of these numbers? It is 1, it is 1 0 and it is 1 1 for 3. So if we concatenate, we will get 1 1 0 and then 1 1. Okay, and then we need to convert this into the decimal number, so it would give 27 and we need to return 27 for this input. N is equals to 3. Okay, so what is the brute force approach for this? What are we doing currently? So brute force approach is, we'll take string str, initially it would be empty, and we'll iterate for int I is equals to 1 to I is less than or equals to n and then I plus plus, and then we are concatenating the strings, right? String would be str plus is equals to, so we need to get the binary representation of this, so we'll use integer dot to binary string method and it will give us, and finally would be having the concatenated string as 1 0 1 1. So 1 1 0 1 1. Okay, so this is fine when we have less number of bits, like around 32 bits. So these are the bits are required to represent an integer number. But here n is can be up to 10 to the power of 5, right? So if n is 10 to the power of 5, to represent from 1, so we need to concatenate now 1 to 10 to the power of 5. So we need lot of bits, right, to represent concatenate from 1 to 10 to the power of 5. And if you want to convert that into an integer number, right, we cannot do that. So there is no inbuilt method, so there is no integer we can use, we can represent with more than 32 bits, right? So what we need to do is, we need to convert the values, right? We need to do calculations on the go. That means while traversing from 1 to n itself, we need to calculate the result. Okay, now let's see from few key observations, right? Okay, so what are those key observations? So if you have 1 0 and 1 1, right, if I have these two binary representation, how can I concatenate these two values? So to concatenate these two values, so we can use, one is left shift operator, right? So what happens if I do 10 left shift of, so what is the length of this bit, which is 2. If I do the left shift of these two, what it would give? It will give 1 0 and 2 zeros, right? It will concatenate 2 extra bits to the binary representation of 1 0. Okay, so now what I have to do? I have to do OR with this 1 1. So I will do 1 0 0 or 1 1. So what it will give? 1 0 0 1 1. It will give 1 1 0 1. So if I see, I was able to concatenate 1 0 and 1 1 using left shift operator and then using OR. So and final we got 1 0 and 1 1. So we are able to concatenate these two numbers. So this is the one key observation, so we can use in our code while traversing from 1 to n, so we can use this logic to concatenate the our two binary strings. Okay, now let's write the pseudocode for our program. What I will do is I will take a bit count. Initially it would be 0, and I will take a result as 0, and then what we need to do, we need to traverse from int I is equals to 0 to, sorry, we need to traverse from I is equals to 1 to less than or equals to n, and then I plus plus. Okay, so first we need to find the bit count, right? How we can find the bit count? Bit count is equals to, we can use, for one thing is we can convert that into the string, and then we can find s dot length, right? So I will do str is equals to integer dot to binary string, right? Binary string of this I, so it would give a string, binary string, and then I use str dot length to find the length of the binary string of that I. Okay, how can we optimize this one? So how we can find is, let's see, if we have 0 1 2 3 4 5 6 7 8 3 0 1 1 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 and then 1 0 0 0. See, if you observe, so these are of length 1, these are of length 2, and these are of length 3. From here it would be of length 4. So if you observe clearly, while traversing itself, at some point one bit is increasing, right? Here one bit got increased, and here one bit is added, and here one bit is added. So how, at what places bits are getting added? So here at 2 to the power of 1, one bit is added. At 2 to the power of 2, one bit is get added. At 2 to the power of 3, and one bit is added, right? So at these places a bit is getting added, right? So how we can find is, if we do I and I minus 1, right? So if we do 2 and 2 minus 1 is 1, if we do this we will get 0, right? 1 0 and 0 1 is 0 0, which is 0. So that means if we do I and I minus 1, and if we got 0, that means at that place a bit is getting added, right? If we do the same thing here also, we have 1 0 0, and 8 minus 1 is 7 0 1 1 1. So if we do and we got 0, so that means here also it is 0, that means a bit is got added. So if we do the other numbers like 6 and 5, which is 1 1 0 and then 1 0 1, so we got 1 0 0, so which is not equals to 0, that means the bits are same. So to find a bit count, is bit added or not, so we can use this logic I and I minus 1. So what I will do is, I will replace this code. What I will do, I will check if I and I minus 1 is double equals to 0, then I will update the bit count plus plus. Okay, so what is the second thing I need to do? So I need to make space for the bit length of this one. So I have bit count with handy, so I will do result is equals to result. I will make space of length bit count, so I will do left shift operator with this bit count, and every time we need to do modulo. Okay, what is the second thing? So once we added the placeholder bits, then we need to add the number I. So I will do result or I, and we'll do the modulo operator. So if we do here, we are making adding the bits to the number result, and then we are adding the integer I value to that number, I mean the result value. So here we are concatenating the binary representations. So we can replace these two, right? These two lines with a single line called result is equals to first we need to do the left shift operator with bit count. So we are making the placeholder bits, and then I will do or with I, and then I will do the modulo. So we can replace these two lines with this single line, and at the end we will simply return the result. Got it? Now let's do a dry run. So initially we will be having bit count as 0 and result as 0, and then for int I is equals to 0, then I is less than n. So what is the first thing? You need to check if your bit count is changed or not. So initially we have I is equals to 1, not 0. So 1 and 1 minus 1 is 0. So 1 and 0 is 0. So if 0, what we need to do? We need to increase the bit count. So now bit count will become 1. Okay. Now what is the second step? Second step is result is equals to result left shift of the bit count, and then or with I, and then we do mod. Okay. So what is result is initially 0. So we'll do left shift with the bit 1. So it will be 0 0, and then we'll do or with I. So if you do 0 0 with 0 1, right, or is it will give 1 and then 0, which is 0 1 only. So and mod will be modulo of 10 to the power of 9 plus 7. So it will give 0 1 only. So result would be 0 1. That means 1. Okay. Now I is increased. I is come to 2. So now I is equals to 2, and I is less than n, true. So it comes further, and here it checks again. The bit needs to be increased. So 2 and 2 minus 1, which is 1. So 2 is 1 0, 1 is 0 1. Right? What is here? 1 0 1 0. So here also bits are changed. So we need to increase the bit count. So now bit count will become 2. Now let's update the result. So result will be initially we have 1, and if you do left shift of 2 bits, it would become 1 0 0, and then what we need to do? We need to add or. So or of I, so which is I is 2. Now if you do add 2 here, which is 1 0. Now if you concatenate 1 0, it would become 1 1 0. So now our result is 1 1 0. Now let's increase I is equals to 3, and I is less than or equals to n, true. Now what we'll do? We'll check if it needs to increase the bit. 3 and 3 minus 1 is 2, is double equals to 0. 3 means 1 1, 0 1 0 means 2 means 1 0. That means if we do and, it will become 0 and it will become 1. So which is not equals to 0. That means we don't need to increase the bit count. So bit count is still 2. Now we need to update the results. Results will be, so we need, what is the result currently, which is 1 1 0. So 1 1 0 left shift of 2, and then or with this number 3. So 1 1 0 of left shift 2 will become 1 1 0 0 0, then or with 3. 3 means 1 1. So if you do or, it will become 1 1 0 0 0, and then 1 1, it will become 1 1 0, and then 1 1. So this is the final value, and if we'll do the mod, and we'll return the result, which is 1 1 0 1 1. Got it? Okay. Now what is the time complexity for this code? Time complexity is, we are traversing from 1 to n, so it would be big O of n. And what is the space complexity? We are not using any extra space, so it would be big O of 1 only. Got it? Now let's try to write code for this. Let's take the required variables first. I will take bit count 0, and then we'll take result as long as 0, and then we need to take the modulo with 10 to the power of 9 plus 7, and then we'll take integer I is equals to 1 2, I should be less than or is equals to n, and then I plus plus. So initially we need to check if we need to update the bit count or not. So how we can check? you can check that I and I minus 1, if it is double equals to 0, then we need to update the bit count. So bit count plus plus. So otherwise we will do result is equals to, so we will update result left shift of bit count, and then once that is done we need to update it with or. So of or with I, and then we'll do modulo. So modulo of mod. Okay, add the missing parenthesis. So first we'll do the add the placeholder bits with doing the left shift operator, then we'll add I to the result. Okay, and at the end we'll just need to return the before returning this result we need to convert this into int, then we'll return the results. Okay, now let's try to run this code. It is accepted. Let's try to submit this. Yeah, solution is accepted. If you like my content, please do like, share and subscribe. Thank you.